And morning once more. We're going to start with our classes. I gave you an opportunity to settle, or those who are still logging in to try to log in. However, I realized that there are very few who are attending, but that it won't stop us from proceeding. We're going to start with our class. Okay, so let me just go to the window journal. It's lecture number 19, and we're going to start a new chapter today. Thank you. Let me just go there. Just wait a bit while I'm still going there. Okay, there we are. Before I start with this lecture, let me just give you some few announcements, and they are very, very important. Number one, I think you want to write quiz number 3, and then some of you suggested that, and then I have agreed to give you quiz number 3, for which we are going to take the best 2. Therefore, I'm encouraging those who failed to write both 2 quizzes to make sure that they write this one so that you can take the best 2. Otherwise, you won't have any other chance. So now, quiz number 3 is going to be written on Thursday next week. I'm saying Thursday next week at 1 o'clock. In other words, it's during tutorial session. So the rest we are going to communicate through the Blackboard. So, but I thought it's very important for me to announce that so that you can prepare yourself. And there are those who fail to write test number 1 and test number 2. So they might possibly write those tests next week, but the dates is still going to be announced. So I just want you to be ready on that. About to test 2, we are done marking. So for now, we are still going to decide when can we give you your script. Are you together? And the pass rate goes down to 57%, if I'm not mistaken. When you still recall that test number 1 was 69%. Yeah, so the rest we'll discuss about that immediately when you receive your script, and I'm still going to give you a feedback. So about a feedback also, we're still going to discuss when can I give you a feedback. But today we are going to start with a new chapter, which is chapter number 6, if I'm not mistaken. It's about systematic random sampling. Are we together? Do you have any question? None. Okay, thank you very much for understanding. Let's start with our class. Like I said, it's lecture number 19. And then it's all about systematic random sampling. Okay. And then you can recall that when we start with this sampling theory, I try to give you some background about the random sampling, and then we try to discuss each, to define each random sampling, including systematic random sampling. So we can start by defining what is systematic random sampling. Actually, I just want to remind you about that definition if you still recall. So let's just go there to systematic sampling, random sampling. What is systematic random sampling? So here the units are selected at a specific interval, starting from a random starting point. If you still recall, we are saying the units are selected at a specific interval. Okay, so you're supposed to have an interval and the starting point. Okay, starting from random starting point. Okay, so in other words, when you want to find the samples based on systematic random sampling, so you must make sure that you have an interval. That's number one. Number two, you must have a starting point. You can start anywhere. That is why we call it a random starting point. You can start anywhere. So now let's consider this example. Let's consider this example. Let's say you have the number of students. Say, consider the number of students okay, lined, okay, so line up in a row, or queue. Okay, let's consider that. Let's say we've got how many of them? Let's say you've got 15 of them. So in other words, we've got 1, 2, 3, 4, 5, 6, 7, up to 15. Okay. So the question is, how do you draw 1 in 5 systematic sample? So the question is, how do you draw 1 in 5? Okay. Sample using systematic random sampling. Okay. That's the question. Like I said, you're supposed to have an interval. You're supposed to have the random starting point, and again you're supposed to have a sample, and you're supposed to have the population size. Okay, sorry. So now in this case, let's say you have a starting point which is 2. Starting point is 2. Okay, it's 2. So in other words, you're starting here. Okay. So now you have to find the interval. So how do you find the interval? Interval, you know that is defined by k, which is equal to the population size divided by the sample size. The question is, do we have a population size? Yes, the answer is yes, we do. So the population size here is 15. Do we have a sample size? Do we have an interval? Okay, that is the question that we have to ask ourselves. If you can check there, immediately when they say how to draw 1 in 5 systematic sample, so that is our interval. So in other words, our interval here is given. The interval there is 5. Okay, sorry. The interval there is 5. So our k is 5. So what about the sample size? So we don't know the sample size. But based on the what? On the population size and interval. So we can find what? The sample size, isn't it? So this implies that 5 is equal to 15 over n, isn't it? So what is our sample size now? Okay, tell me, what is our sample size? It's 3. Thank you very much. Our sample size is 3. Okay, so now you have got the interval, you have got the sample size, you have got the population size. So we just want to find what? So in other words, n equal to 3, we just want to find 3 primary units. Okay, so in other words, because the sample size now is 3 here, so we just want to find the 3 primary units. So how do we do that? How do you do that? It's simple, because now you have got a what? A starting point. So let's scroll up there so that you can see the starting point is 2. So if we check, 2 is here. 2 is here. We are starting here. And the interval is what? It's 5, is it? Isn't it? Yes. Interval is 5. So that means the next, remember, we want to find 3 primary units. So that means the starting point is 2. Start at 2. So the next value will be what?
7.
7. Thank you very much. And the next one?
So can you go up a little bit?
12.
12. So this one, 2, 7, and 12. This is our first primary units. Okay, then we go. The next one will be, let me just write it below that one so that you can follow. Let me just write it below. The next one is going to be 3, isn't it? Primary units. So you've got 3. So for the second primary unit, it's 3 and what?
8.
8. And the next one?
30.
30. So this is the second primary unit. So the third one, so it's going to be 4, and then 9, isn't it? Then 14, and so on. So those are the 3 primary units that we are talking about, especially when you are dealing with the what? Systematic random sampling. Okay, let me just give you another scenario now. How do you, sorry. So let's say I give you another scenario. How do you draw a 1 in 3 systematic sample? So let's say the starting point this time around is 3. Okay, it's 3. And then, so you have to find the what? the interval, find the population size, find the sample. So again, population size is going to be the same thing, it's 15. Okay. And then the interval is what? You can tell me. The interval?
3.
It's 3 at this time around. Okay. So what about if the interval is 3 and the population size is 3? What about the sample size?
5.
It's 5. Thank you. So now you have got the population size, the interval. So now we just want to find, let's say, find 5 primary units. Okay. And the starting point is 3, like I said. So let's start. So it's 3, then
6.
6, and then
9.
9, isn't it? Then follow 4, then
7.
7, isn't it? Then
10.
10. Like that. Remember, we need how many? 5 of them. So it's 5, 3, 8, 3, 11. Then 6 plus 3 is 9, 3 is 12. And remember, those values, all of them must be between 1 and what? But because now we are starting at 3, so but it's supposed to be between 1 or 3 and 50, so to speak. So the next one, which is the last one, sorry. Which is the last one, because we need 5 of them. 7, 10, and 15. Those are the 5 primary units that we've been looking for. I think it's clear. So now let's go to how do you estimate the
Sir.
population mean? Okay.
The 3, the K is equals to 3. Is it the 3 units in the sample?
K is the interval. K equal to 3 is the interval. In other words,
so
the interval, we mean this.
I want to know
Sorry.
why are we having 3 values in the bracket and not 5?
Oh, 5 is just the number of what? The samples that we're going to say. Remember, we're talking about primary unit samples. This 5 just represent these 5 primary units. Okay. So, in other words, you can just have 5 of them. It doesn't have any effect anyway. You can have 5 of them. But in a case, we just want to have 3, 3, 3, 3, and so on. You can just have 5 of them, depending on what you want to do there. So I think there is no harm on that.
Okay.
Okay, how do you estimate the population mean, population total, and the variance under systematic random sampling? Okay, let's start. Estimation of the population under systematic random sampling. In other words, you're going to estimate what? Mu SY. Okay. We are going to estimate that. So how do we do that? So the formula that we are going to use, it can be new estimate SY, okay, which is equal to Y bar SY. Okay, this is how you estimate the population mean under systematic random sampling. So now, which is equivalent to what? To the sum of yi divided by the sample size under systematic random sampling. Okay. So the question is, how do you estimate the variance of that estimated mean? So the estimated variance of the estimated mean under systematic random sampling, which is y bar as well. Okay, it's given by var estimate y bar sy. Okay, which is equal to what? N minus n divided by n. Close brackets. Then multiply by what? By sample variance under systematic. Then sample divided by sample size. This is something that you know. The only difference is that here you are dealing with the systematic. So that is why under sampling variance, we just indicated SY to indicate that indeed, in this case, we are dealing with systematic random sampling. So now, how do you estimate the population total? So the estimated population total which is what? Tau SY, okay? It's equal to what? N Y bar, you know that, isn't it? N Y bar. So what about the estimated variance of that estimator? So the estimated variance of the estimated population total, in other words, tau SY estimate, is given by the var estimate of what? Of tau SY estimate, isn't it? Which is equivalent to the estimated var of what? NY bar. SY. I think you are familiar with that. So this now it can also be written as what? It can also be written as what? N squared estimated var of Y bar SY. And you know that the estimated variance of Y bar is equal to what? That one. So therefore you can substitute. So it's n squared n minus n over n, simple variance over n, isn't it? Therefore, this to the sea to the ocean, then we are left with what? N open brackets n minus n multiplied by sy squared over n. So this is the estimated variance of the estimated population total. Okay. So, how do you estimate the population proportion under systematic? Just scroll down. Sorry. So the estimation of the population proportion estimation of population proportion under systematic random sampling. So we're going to have what? PSY estimate, isn't it? Okay, which is equivalent to Y bar SY, if you still recall, and this is going to be equal to summation of YR over N. Okay, I think you are familiar with that. So what about the estimated variance of that estimator? So the estimated variance of the estimated population proportion under systematic, which is PYSY estimate, okay, it's given by var estimate or PSY estimate, okay, which is equal to what? PSY estimate QSY estimate, then brackets, then here you can divide it by n minus 1, okay, then brackets n minus n divided by n, close bracket. So this is the estimated variance of the estimated population proportion under systematic random sampling. Okay. So, and this can also be written as what? Can also be written as what? PSY estimate 1 minus PSY is an estimate. Then you divide it by what? By n minus 1. Open brackets, n minus n over n. So still the same thing. However, if the population size is not given, so you just ignore this part. If the population size is not given, this part has to be ignored, and you have what? PSY 1 minus PSY estimate divided by what? N minus 1. In other words, what you are saying is that you have got n minus n over n, and this one you know that is the same as n over n minus n over n. Okay, which can also be written as what? 1 minus n over n. Okay, and this one we just assume that is equivalent to 1. Yeah, something like that. Then this, we're not saying this part is 0, so we just take it as what? Yeah, we just take as this equivalent to 0. So then the whole of this part, we take it as 1. Take it as 1. If we don't have the population size. So that's why I'm saying you can just ignore this part if the population size is not there. And then we use this one under population proportion. So does it? So now let's go to the sample sizes. before we
So you think we
just
can use that
consider
one
the
when what
example.
happens?
Eh?
We can use the formula there when what happens. I didn't catch that.
Which one?
The one in black.
Oh, I was saying that if the population size is not there, it's not given, so we can just use this one and take this one as one. Okay. So we are allowed to use this one and then you just ignore this one. Still remember when we were estimating the variance, when we were saying that the square root of S1 over N1 plus the square root of S2 over N2. Still remember that we were using this formula because the population size there was not given. So otherwise we were supposed to include that other part of n minus n divided by n, I think. So, but because we didn't have the population size, so we ended up having only the square root of S1 over n, 1 plus the square root of S2, or square root over n, and 2. So this, we apply the same scenario here. So here, because the population size, we assume that it's not there. So we can just take it as 1, and then we consider only this part, which is what I wrote it here. Only if the population size is not there, or population proportion. That's what we are trying to explain. Okay, now the sample sizes required to estimate the population proportion under systematic random sampling. Just go there. Then from there we go to the examples. Sample size required to estimate population proportion under systematic. So it's given by n equal to npq over n minus 1 times d plus pq. Remember, this p here, this one, this p here, represent the population proportion. Okay. However, if the population proportion or the true population proportion is not given, you have to estimate it, isn't it? In other words, this one can also be written as what? NP at Q at. If the population proportion is not given. So you can estimate it and use this one as well. D plus P at Q. It's the same thing. Are we together? So, but normally it's coming from this formula. We are estimating the sample size. We're finding the sample size required to estimate the population proportion. So using this one, n equal to npq divided by n minus 1 plus pq, which is the true population proportion. However, if it's not there, so you can estimate it using this formula. There they say. The black one, you use it if the population proportion is not there, so you have to estimate it and then find the sample size. I think it's clear. And then you know that n also can also be written as what? np 1 minus p, isn't it? So divided by what? By n minus 1 times D plus P 1 minus P. The same thing. Where in this case, D is equal to the bound squared over 4. D is equal to B squared over 4. B is the bound on the error of estimation of the population proportion. I think it's clear. So, any question before we go to the examples? None. Okay. Let's quickly go to the example. Example. I don't know which example is that. Let me just check. But obviously, example 6.1 because we're in chapter 6 now. So now you can take your lecture notes if you're reading it. Example, no, it's not 6.1. It's not 6.1. It's 6.4. Let's go to 6.4. Example 6.4. That is page 50 in the lecture notes. And it's talking about the management of a particular company which is interested in estimating the population proportion of employees favoring a new investment policy. And they said 1 in 10 systematic sample. Okay, let me just write this information. He said 1 in 10 systematic sample is obtained. Okay. 1 to 10 systematic sample is obtained from employees leaving the building at the end of the particular working day. So the results are summarized in table 6.1. So table 6.1 is summarized in this follows. Let me say table 6.1 summarized as follows. We have got the employee sampled. Okay. And then we've got the responses here on another column. Okay. So they start with 3, then 30 employees, 23 of them, and so on, until they reach what? 1,993 employees, which is 993. Okay, that's the last one. Here the response, they say those who said yes, there are 3, and indicated by 1. No, I think is 0. 1, those who say yes, and so on. And here it's 1. Okay. Now, and then from there you've got the total here. You've got the total, and then they find us sum of yi from 1 up to what? Oh, there were 200 of them. Okay, it's equal to what? 132. This is the information given. And the question says, estimate the population proportion in favor of the new policy and place a bound on the error of estimation. In other words, we just want to find P hat. Just want to find P. This is what we are looking for, okay? And then from there, we find a bound. And you know that the bound is equal to 2 times what? The square root of what? Estimated var of PSY, isn't it? So in other words, you estimated the population proportion. From there, you estimate the variance of the estimated population proportion. Then later, you find a bound. So let's start. How do you estimate the population proportion under systematic random sampling? Where do we start? There are information given. Okay, they say 1 in 10 systematic sample is obtained. They summarized everything in that data. And then later they ask you to find what? They estimate the population proportion. So my question is, how do you find P at how do you find P at this one? Can you find it for me?
It's 132 over 200.
Okay, so okay, another thing, you're reminding me of something here. When you are solving a question, okay, like this one, you want to estimate the population proportion under systematic random sampling. The starting point, you have to write a formula, please. You have to write a formula, you know that this one is equivalent to yi over n, isn't it? So there are those who just quickly go to the answer, like this one. You said is what? 132 divided by what?
200.
Divided by 200. That's what you are saying. Okay. So
0.66.
when you estimate the population proportion, you have to write a formula. Then from writing a formula, you substitute. Then you find the answer. There are 3 steps. Write a formula, substitute, then give me the answer. Because if you can just come here and then you forget about the formula, you just do it like this. And then he said P at SY is equal to 132 over 200. What does that mean? Because there are those who were doing it in a quiz. I was marking a quiz. I realized that somebody just substitute something. You are substituting that values from where? That is the question. So you have to be careful about that. So you're supposed to write a formula for me. Summation of yi over n. Then equal to this one, divided by this one, then equivalent, then you tell me the answer. Because if you just substitute the numbers without knowing where is it coming from, I will give you a 0. And I realized that those who were doing that, they were copying. And they realized that the time is no longer on their side. Then they just forget about the formulas and then they substitute. So when I comes there, I just draw a line because you're substituting something that I don't know. So we have to follow the procedure. I need those steps one by one. Okay. So be careful when you write those assessments. Substitute everything. I must see that whatever you are substituting there is coming from where. Did you follow all these different procedures there? It's not the matter of just writing the answers and then he said, okay, the answer is this one. I think I'm clear on that one. So he said the answer is what? 0,
66.
0.66. So this is the estimated population proportion under systematic random sampling. This is the estimated population proportion under systematic random sampling. Okay. So now, this is the answer. Now we have to proceed and find what the bound. Before you find the bound, you have to find the estimated variance of that estimate that you have calculated up there. So that's step number 2. You have to find the estimated var PSY. Okay. And the formula is what? So before that, how did you arrive at? Isn't that you are saying that the sample size here? Just a question. You're saying a sample size here is equal to what?
200.
200. Okay, that's true. The question is, how did you find that indeed is equal to 200?
It's given there on that summation.
It's given up there. That's true. This is the one. So the question is, what about if they didn't give you like that one? Okay, they just say, okay, here, they just say, for argument's sake, okay, they didn't write this one, okay, they just write summation of yi equal to 132. I'm just giving the scenario if it's like that. Okay, will you be able to find the sample size n?
We're going to use the interval.
Yes, thank you very much. You have to go back to that k equal to n over n. Okay, they gave you the interval, which is what? I think it's there. They give you an interval as what?
10.
10. Eh?
Yeah.
The interval is 10. And the population size? Oh, I forgot to give you the population size there. They said, according to that question,
2000.
2000.
yeah, 2000. I forgot to give you. It's down there. It's written there. They said assume that the population size is 2000. It's given. Sorry for that. So they gave you the population size, so you have to use it. Then divide by n. Then your n will be equal to what? Sample size will be equal to what? 200. So you have to be careful about that. Sometimes they won't give you the population size, and then you want to find the sample size. So you can be able to find the sample size using this formula. Okay, think it's clear. Now let's go back to our question now. Estimated variance of the estimated population proportion. It's equal to what? PSY QSY divided by n minus 1, n minus n over n. Can you find the formula for me, please? The answer, sorry.
You want the final answer of the substitution?
Substitution, sorry. Let's start. Let's go through
0.
substitute.
66.
0,
66.
Okay, 0.66. Then
1 minus 0.66,
which is
0.44.
then divided by n minus 1 is what?
199. 200 minus 1. 2000.
N minus
2000 minus 200.
Sorry, more
200.
as 0.34.
Come again?
More
Oh,
Q.
0.
Oh, yeah, 3 fours.
Yeah. Thank you for that. 0.34. Let me just delete this one. $200 divided by 2000. Yeah, now I'm looking for the final answer.
One comma 0149 times 10 to the power minus 3.
1,0.
Eh,
1,3.
what?
1,03 or 1,3?
Zero 1.5.
Repeat again.
0.15.
1,015 or 0.15?
0.15. 1,015.
This is the answer.
Multiply by 10 to the power negative 3.
Then the bound, sorry, is equal to 2 times the square root of, you have to write it like this, bar of PS, which is 2, 1,015. The final answer is
0.064.
like this.
Yes.
Everybody got it right.
Yes, sir.
Okay, so it's fine. Now let's go to another example. Is it example or exercise? Yes.
On the bound, the variance head, we substitute the rounded value or the full
Take
value
it as
that
a
we got
whole.
there.
I think it's better to take it as a whole.
All right.
Okay, let's go to example 6.5 there on page 5.1, I think.
Hey, sir,
Hmm.
where did you calculate the K?
Why or where?
Why? Like, because I don't see where you used it.
Oh, I was saying that if, let's say here, if they didn't, yeah, you see here, we're summing from I equal to 1 up to 200, isn't it? So you know that
Yeah.
obviously your sample size is 200. Then I said, for an example, what about if they just say, okay, the summation of yi is equal to 132? They did start from I equal to 1 up to what? To 200. Can you be able to find the sample size, this one now? Then somebody said, yes, we can. We can use this formula here. K equal to population size over sample size to find what? The sample size, which is 200. So that's why this formula comes in here.
Okay, I see it.
Okay. Now, let's go to example 6.5 then. Example 6.5. I think it's page 50 in the 10 notes. Again, it's talking about something management again. Just try to summarize it. It's talking about the management of a large entity company. It's interested in the average amount of time delinquent bills that are overdue. A systematic sample will be drawn from alphabetic list of the population size of, so the population size is given there, 2500. Population size list, the population size of 2,500 overdue customer accounts, okay? In a similar survey conducted the previous year, the sample variance was found to be, so in other words, they give us the sample size. Sample variance, sorry. Sample variance, which is 100 days. The question says, determine the sample size required. Sample size required, that's the sample size required to estimate the population mean. Remember, we said the population mean, mu sy, is equal to psy, I think. Because all of them are equal to what? Summation of yi. The question is determine the sample size required to estimate the population mean. In other words, they say the average amount of time utility bills that are overdue, with a bound on the error of estimation of b equal to 2. In other words, our b here is equal to 2. So they gave us the population size, they gave us the sample variance, they gave us the bound. They want us to find out the sample, determine the sample size. Straightforward, isn't it? Can you find it? Can you find it and give me the answer, please? Or tell me the formula. Which formula are we going to use? N equal to, this is the formula. Let me show you. I think it's up here. This is the formula. However, here we're not talking about the population proportion. We're talking about the what? The variance. So in other words, instead of this one, we're going to have what? Oh, sigma squared. Is this sigma squared? Yeah, sigma squared. And here, we're going to have sigma squared. Are we together? So this is the same formula that we're going to use. The only difference is that instead of population proportion, you're going to use the variance. So What I'm saying is this squared over n minus 1 times d, but the d, we know that is what? D is equivalent to what? B squared over 4, isn't it? So you can just use b squared over 4 plus the variance. This is the formula that we're going to use. So please substitute and give me the answer.
$96.191.
Come again?
96.
126
96.
96 96 what?
0.191.
Okay. So because it's a sample size, you have to take it to the whole number. It's what?
97.
97. 97. Don't leave it as it is. When you write this, you have to write the formula. Okay, that's first step. The second one is substitute. Okay. The third one, you give me the answer, which is this one. Then because it's a sample size, you round it to the whole numbers, which is this one. Because at the end of the day, when you are finding the sample size for each stratum, if we are talking about the stratified random sampling, so you are going to use this one. The overall sample size is this one. You don't use this one. Are we together? So you have to be careful about that. So the final answer is n equal to 97. That's simple.
Sir,
Yes.
sir,
Yes, I'm listening. I can hear
it's
you.
197, not 96.
Come again?
Why
I didn't hear
97,
you.
not 96?
It's what? One?
Why 97, not 96?
Are you saying it's 197? I can't hear you. Your
Is
voice is
why,
down.
not 96.
Hmm?
So I'm asking why all rounding to 97, not just 96.
Oh, I think from the beginning when we've been dealing with the sample sizes, I said if you have any commas or any digits, you have to round it off to be a whole number, especially when you are dealing with the sample, because we don't have a sample of 2 comma something, 10 comma something. We are having a sample of the whole number. If you are dealing with the sample of 20, it's supposed to be 20, not 20 comma some, not 19 comma something. But if it's 20 comma something, it's 21. It's a whole number. As long as you are having some digits there, like this one here, you have to round it off. Unless if it's 96,000. So this one is 96, obvious. But if it's 96,01 something,
So if it was
so you have to round it off.
96.097, you're gonna.
If it's 90 what? 96 comma?
If it's 96.097,
97. Obvious, you're going to take it to be 97 because of these digits, these numbers. As long as you have some numbers there, except the zeros, you have to round it off to the whole number.
oh.
Yeah. Okay, let's go to the last example, but in this case it's an exercise. It's the last one, so the rest we're going to do them tomorrow. Page 52. It's on page 52. Okay, lecture notes. And it's exercise, written exercise 6.1. Okay, this one again is talking about advertisement. It says an advertisement firm is starting a promotional campaign for a new product. The firm wants to sample potential customers in a small community to determine the customer acceptance. To estimate some of the costs associated with the personal interviews, the investigators decided to run a systematic sample from the population size of 5,000. So the given information is n equal to 5,000. Okay. From the population size of 5,000 names listed in a community register, and collect the data via telephone interviews. Now, determine the sample size. We want to find n. Determine the sample size required to estimate the population proportion. You want to estimate? Let me just write it as p hat. To estimate. Determine the sample size required to estimate the population proportion of people who considered the product acceptable, with a bound on the error of estimation of magnitudes. In other words, b equal to 0.03. They said it's 3%. In other words, 3% is 3 divided by 100, which is 0.03. That is our bound. We want to find the sample size to estimate the population proportion. I think it's the same thing. The same thing that we did before, I think so. Because you need to find n, okay, n times PQ. This time around, it's no longer the variance or the sample variance. It's PQ, it's population proportion. Then you divide by the same formula is D. So because you are estimating the population proportion is B squared over 4, then plus PQ. This is the formula that we are going to use. So can you please substitute for me? I think even this one is a straightforward thing. Anyone who can do that for us, just do it and give us the answer. answer? Or can we substitute if you are struggling to get the answer? Population size is what?
$5,000.
5,000 multiplied by P is what?
0.
0.
0.5.
Yeah, thank you very much. 0.5. Q 0.5, isn't it? Then you divide it by 4,999. Then a bound 0.03
0.0
squared.
squared.
Divided by then plus 0.5. Yeah, now you can give me the answer.
909.24.
909.224.
Yeah.
24. Everybody got it right. Got the same.
Correct.
Therefore, give me the rounded off.
910.
910. So it's 910. Yeah, I think this is the correct one. Let's stop here. Any question?